In this video, I'm going to explain the HVAC design for a pharmacy clean room in a hospital setting. So the first thing that I'd like to identify are the rooms that go into making a pharmacy in a hospital. So the most important room is the clean room. This is where the medications are created and filled. It's over here. The ante room. This is where the pharmacists get gowned up to move into the clean room to prepare the medications. And then you also have the pharmacy area here, which is where everything gets packaged up to be sent to the patient bedside. So in order to build this system, there are a couple of standards that have to be followed in how it's created. So one would be the ISO 7, which is the International Standardization Organization, which has classifies the particulate count and classification for each of the rooms. So our clean room here, where the medications are created, is the cleanest area, the highest standard in the pharmacy. And then we also have ASHRAE 170, which talks about airflow, pressure relationships, and the ventilation criteria. So between ISO 7 and ASHRAE 170, those two are the Bible as far as how the systems are to be built. So I'll start describing the clean room here. So obviously the system itself has to have constant volume of air. ISO 7 needs 20 to 40 air changes per hour in that space to keep it a controlled environment, sterile. So there's got to be constant flow in and obviously constant flow out. So if you notice what I have here for the three rooms that we have, the most positive for flow of air has to be in the clean room. And then it transitions to the ante room, then to the pharmacy, and the pharmacy has to be slightly higher than the corridor as well. So the purpose is so for instance, if we were to bring in, 2000 CFM of air and positive air coming into the clean room, we'd probably want to take somewhere around 1800 CFM out constantly. And that would leave us with, 200 CFM or so to get to the ante room. And the ante room has a similar, that one follows criteria for ISO 8, which is a little bit less than your clean room. So probably about 20 air changes per hour in this room. So that positive pressure of this room will be slightly less than this. So we don't want what's in the ante room going this direction. We want all the flow to be going clean room, ante room, and into the pharmacy and back into the corridor. You don't want any backflow of air. So one important thing I want to just show here is the laminar hood in these clean rooms. This is where, this is the most sensitive area all within the clean room. This here has a laminar hood, which is a glass enclosure that pushes the airflow from above down through another set of filters to get into the ISO 5 category. And that's going to be a vertical force down, and it gets drawn out the bottom of the hood. So this hood, where the medications are actually in a very controlled environment, this one has the highest standard of everything, and that is like I said, the laminar hood is a vertical flow of air that comes down through so that there's no contamination of any kind. There is a pressure alarm panel, so you will have pressure sensors in each of these spaces that will all get populated on your panel in the pharmacy to make sure that doors aren't being left open, etc. So again, this is very critical for not only the staff of the pharmacy, but also the facility staff that's monitoring it, to be aware of the relationships room to room and what they have to be. And obviously, if there's, alarming, that something's got to get addressed immediately. The design of these is only as good as the the employees of the space being aware that they exist and what rules that have to be followed, etc. So it's critical for facilities teams and personnel to be educated on how the airflow and pressure relationships are in the pharmacy. If you found this video informative and valuable, I'd appreciate the share to your network. Thank you.